first of all, you need to take one white sheet that you are going to fix on the drawing board. Now suppose this is a glass slab. This is a glass slab, thick glass slab. You have to keep this glass slab on this white board. First, on the drawing board, you are going to fix this white sheet by means of thumb pin. Now this glass block you have to place here and draw its outline. Let this outline be A, B, C, D. Okay, name this outline of the glass block as A, B, C, D. Now what to do? Remove the glass block and nearly at the middle of AB, you need to draw a normal. You need to draw a normal and a particular light ray as incident ray at any particular angle of incidence. You have to mark this incident ray. Now on this line you have to fix two pins. Let one pin is P, another pin is Q. So on this incident ray at 2 points we fix two vertical pins P and Q. Now again we replace the glass block here. Okay, so once again I repeat what you need to do. This is a white sheet. This white sheet you have to fix on the drawing board. Now nearly at the middle we need to keep a glass slab and draw its outline and level it as A, B, C, D. Now remove the glass block again. Nearly at the middle of AB you draw a line which is perpendicular to AB and draw one incident ray. Let this is the incident ray at any particular angle of incidence. Now at 2 points P and Q, fix two pins P and Q. Now again you keep the glass block in its place. Now you observe from this side through the glass block. The pins P and Q should be observed through the side CD of the glass block from a particular point. Now P can be seen somewhere here, Q can be seen somewhere here. Let this is P dash, this is Q dash. Okay, this point is A. Now due to refraction, P and Q cannot be seen in its actual place. P is seen somewhere here, Q is seen somewhere here. Now seeing these two images, you have to fix two more pins, say R and S, in such a way that all the four pins appear in the same straight line. Which four pins? P dashed, Q dashed, R and S should be seen on the same straight line. Now remove this glass slab. As you remove this glass slab, this P dashed and Q dashed will be vanished. Okay, this P dashed and Q dashed will be vanished now. Now you join R and S. These two pin marks already there. You join R and S. And again you join this line, these 2 points through a line. Now let us say this point is PQ. Let us give a name MOTS. MOTS. S is already there, so let us make it S dashed. So what is MO here? MO is the incident ray. What is OT here? OT is the refracted ray. And what is TS test here? This TS test is the emergent ray. Now taking O as center and any radius, you draw one circle. Taking O as center and any radius, we need to draw a circle. What is this angle? This is angle of incidence, can be measured by protector or can be decided by the experimenter. Any particular angle can be taken. So this angle is I, this angle is R. So we make a table like this: number of observations, I angle of incidence, R angle of refraction, sin I, sin R, and then sin I by sin R. This way we make a table. Now, suppose observation 1, observation 2, observation 3, observation 4. Suppose you are taking 4 observations. So what we need to do, first observation, suppose you are trying with angle of incidence 30 degree. It means this angle, suppose you are taking 30 degree. Now corresponding value of R you get and write it here. Second set, suppose you are trying it with 40 degree, corresponding value of R you write here. Third angle, suppose you are doing with 50 degree and then it is with 60 degrees. So for 4 sets of I, you are getting 4 sets of R. Now for every set, you find sin I, sin R and sin I by sin R. It can be observed that the value of sin I by sin R, that is the result of last column, will always come same, though I and R are different for each observation, which verify the law of refraction, which states that refractive index equal to sin I by sin R, which is constant for a pair of medium. When you have drawn this circle, then from this point you throw a perpendicular, from this point you throw a perpendicular. Suppose this is OVL, OVL, and another is say let us take it as XY. So we have two right angle triangle. One is OVL, one right angle triangle, and in this right angle triangle, angle L equal to 90 degree. And another right angle triangle we are taking, that is OXY, and in this triangle, angle X equal to 90 degree. Is it clear to all of you? VLO is a right angle triangle. Here this angle is 90 degree. And OXY, here this angle is 90 degree. Now, in triangle VLO, what you can say? Sin I equal to VL by OV. VL by OV. And if you consider the triangle OXY, in triangle OXY, we'll be getting sin R equal to, what we get? XY divided by OY. XY divided by OY. So what is sin I by sin R? What is sin I by sin R? That is VL by OV divided by XY by OY. This we get. So the result is VL by OV into OY by XY we get. Now OB and OY both are equal. OB equal to OY, that is the radius. That's why OB and OY we can cancel out. OB and OY we can cancel out. So what we get? We get sin I by sin R equal to VL by XY. To find out the refractive index of the material of glass, we measure the length of VL, we measure the length of XY, and both of these two values we write here, we divide, and the result we are getting, that is the refractive index of glass with respect to air. So you can understand on the basis of this calculation that after drawing this circle, what you need to do, you have to project the point V on this normal, you have to project the point Y on this normal. And from this projection, you have to measure the length of VL by scale and you have to measure the length of XY by scale. And you divide these two values and that result the refractive index of glass with respect to air.